Hello, this is Mr. Stansbury. I'm going to take you through the 19 e-notes on simple rules of differentiation. Okay, at the end of this, you should be able to say, I can calculate the derivative of a function using the rules of differentiation and interpret its meaning. Okay, so we've something to kind of help us out here in figuring out differentiation is we need to remember that the slope of a line is y2 minus y1 over x2 minus x1. Or in other words, really the slope is the change in the y. That's why we subtract the y's from each other to see how much it's changed, divided by the change in x. So we're seeing how much the x has changed, right? So this is the change in y over the change in x. Okay. Just as a quick sidelight, you could possibly see this as this little triangle y over triangle x. The triangle is actually stands for delta y over delta x, and delta stands for change. Okay, so the change in y divided by the change in x. Okay, that's another way you could possibly see this here. All right, now with that, for example, the if we let's say we have this curve here, and again, you'd have to just imagine that this pink curve here is the same in all three pictures. So we could find the slope of the line if we find these 2 points. Okay, you can find the slope of that line by doing just the regular old slope formula, y2 minus y1 over x2 minus x1, again, which is the change in y divided by the change in x. Okay, as those 2 points get closer together, again, we still have the change in y over the change in x, but this gives us a little bit closer picture as to what the slope is at this point that's right in between these two. Okay, and then now here's where we do a little tie into limits. As you approach this exact point, this is actually considered the tangent line to the curve. Okay, so as we approach this point here, so basically as the limit approaches, we can again use limits to get really, really close to this point. Okay, this tangent line here to the curve is the derivative. Okay, and differentiation is, well, here I won't not get too far ahead of myself. That's coming up next here. Differentiation is the process of finding the derivative or the gradient function or the slope of the tangent. Okay, so again, differentiation is just another word for finding the derivative. Okay, so when you see derivative, you'll often see it like this, dy over dx. Okay, and again, this reads dy by dx, which means it's the derivative of y with respect to x. So x is the variable. Okay, and now please note that this is a notation and it's not a fraction. You don't take d times y divided by d times x. That's completely different. This is just notation, dy by dx. Okay. Now, there are rules for differentiating functions on page 615. Okay, I think there's 4 different ones, and there's one primary one that really kind of is the big one that you need to know. It will really pretty much take care of everything that we're going to cover in our course here, and that's this. And again, this may not make a whole lot of sense until we put it in action. We're going to put it in action here in a second. Okay, so f of x equals x to the n power. Okay, so that's our function. So then we say f prime of x, and this here just stands for, this f prime of x is the derivative. Okay, so f prime of x is the derivative, dy over dx is the derivative, and there's also, I'll try to show you a different way of notating the derivative. I'm not trying to throw curveballs at you or anything like that, but just in case you run into this in college at some point, then I want to make sure that you're familiar with all the different notations, at least the common notations. Okay, so what this is saying is to find the derivative, if this is your original function, you take this n and you multiply it. So basically this n comes out front here, so you can see the n comes out in front, and then you just subtract this power by 1. Okay, so this n comes out front, and then you subtract 1 from that power, and that's simply the derivative. Okay, so again, let's put that into action. with this one here. So we're going to find the derivative of the function f of x equals x squared. So we're going to do this. F prime of x, which again this means derivative, is x squared. So what we're going to do is this 2 is going to jump down front here. So we go 2x, and then we're going to subtract 1 from this power. No matter what, you're always going to subtract 1 from that power. So 2 minus 1 is 1. All right, so we get f prime of x equals 2x. Okay. Again, the other way that we would see this is you could see dx, oh, excuse me, I already got it backwards, dy over dx is 2x. And then another familiar notation that you could possibly see on this is d over dx. Is that right? Let me double check. Yeah, this is right. D over dx equals, and actually you don't even do the equals first, you got to put the parentheses and then you just name the function. So x squared equals 2x. So really that would, this really up here should, to be consistent here, this should be y equals x squared. Okay, so this is saying the derivative of this function y with respect to the variable of x is 2x. Okay, and then the other notation you would see, which we're not going to deal with in our class, is d over dx of the function. So what they're doing basically, this y here is saying it's, oh, hey, we're taking the derivative of this function here. This is just saying the general derivative. So you actually have to name the function that you're taking the derivative of. Okay, so again, all three of these things here all say the same thing. Okay, enough of that. Let's do some more derivatives. Okay, so this one here, 3 comes out front. So again, let's be consistent with this. This is y equals, y equals, and so this really is f. Well, I guess we can leave it and we can do f prime of x. Let's do that. F prime of x is, move the 3 out front, 3x, and then we subtract 1 from that, so it's 3x squared, and that is the derivative of that function. And you thought derivatives were going to be scary. They're not. It's not that bad. This one here, there is no x, so what you want to do is write x to the 0 power, right? This 0 comes out front here, so f prime of x is 0 times 4, and we know that 0 times anything is simply going to give us 0, right? So it would really be officially 0 times 4 to the negative first, but again, 0 times anything is going to give us 0, so there's our derivative of that. All right, let's look at a few more things, and then away we go. All right, so this here, this is example 5 from page 615. Yeah, 615. And these here are some derivatives, and they're a little bit more challenging, I guess we'll call it that way, because now you've got several pieces to take derivatives of. Okay? So what you want to do here is you're just going to take the derivative of each function and just add them all back together. So the 3 comes out front here, so f prime of x, so we get 3 times, here, let's write it out, 3 times 5, and then we have x to the, let's do this, 3 minus 1, plus 2 comes out front, 2 times 6x, and we take the 2 and subtract 1, and there's a little first power right here, right? So we do minus, and then we have 1 times 3, x to the 1 minus 1. And remember, this is x to the 0, so that 0 comes out front here, plus 0 times anything. We don't have to worry about because that's just going to turn into 0. Okay, so to simplify this here, we get f prime of x, or the derivative, is 15x squared plus 12x to the first, or just 12x. And then this turns into x to the 0, and then we have negative 1 times 3 is minus 3. Okay, so there's our derivative function of this. Okay, we're just about at 10 minutes, so I'm going to stop it here, and then the second half of the video we'll do these examples, and then one other set of examples. All right.